is some overview of the techniques that people are working on in fairness in machine learning, why fairness matters. And I want to explain there are some opportunities and challenges because it's a new topic. One of the opportunities is that, as I told you, like most of the people when they are thinking about fairness in machine learning, they consider it as the constraint. Considering the fairness as a constraint, meaning that we reduce the space. So there is always a cost for fairness. But there is a way to actually satisfy both property. So why we need to think about fairness as a constraint? We can actually think of a fairness as satisfying two optimization problem. And parent to front, for example, is a very, very interesting way of doing it. But people are not really thinking about it. So if you are interested, I encourage you to work on it. Another thing is that fairness is different in different applications in machine learning. So for instance, in recommender system, defining fairness is pretty hard. Why? Because we are not just having, for example, the users of the system. We have two types of users. We have providers, for example, the Amazon. Like we have big companies that are providing products, and we have small companies providing products. Fairness, we can define it in terms of like which company we should show the product to people. Also, we have users, and that's based on, for example, their sensitive attributes. So defining fairness in this context is a bit different than binary classification. Also, in graphs or in networks, it's also very, very hard to define fairness. For example, in influence maximization, when we want to select a set of nodes to maximize the influence in the network, it is really hard to just define it based on the attributes of the nodes, because the structure of the graph actually influences on the receiving this, for example, positive opportunity or not. And as I said, there's linking biases. So if there is a differences between the pattern in the network, we have some problems. So it's harder to define fairness in this context. Also, there is another challenge about the complexity. So most of the times, we have systems which are a combination of different machine learning tools. So for example, in a sequence, we are using one machine learning tool. The outcome is going to be used in another system, and et cetera, et cetera. So if you have a bias in one of them, it can actually propagate, first of all. And second of all, if we are just solving it independently, it doesn't necessarily mean that we actually have a fair system. So Cynthia Dork, it has a couple of papers talking about this fairness under composition and saying that like satisfying group fairness or individual fairness in single case, it's not satisfying fairness for the whole system if you have a couple of these systems. Another challenge is that most of the times, people are taking care of one sensitive attribute. So they're just population of female versus population of male. But what about subgroups? So in the case of gender shade, they actually showed that if you're thinking about the recognition of face for female and male, in general was kind of okay. But if you look at the black women, it's really, really bad for them compared to even black male. So subgroup matters, actually. Another thing is that why we should always think about like gender as a binary. We actually discussing about like we don't have binary gender. So we need to think about like how we should consider it when we are thinking about fairness. Or for example, sexual orientation or race. These are not binary, and we need to think about like more classes. Also, the communication is not clear. So I told you about this data. So we can manipulate the data and learn machine learning model based on the balanced data. But is it legal? Can we actually change the data? Or can we actually, when we are using this algorithm, when we're going to the courts, can we use this fairness metric to like saying that we are fair? Which fairness metric we should use? And like convince the courts that we are fair, for example, here. When we have a product which are used in different countries, so which law we should follow? Should we address the law in the US or in Europe? And it is different, so we have to consider it. So these are the questions that we need to answer. But I will finish this presentation with some takeaways. So if you are going to work as a data scientist, or you are going to build this deep learning tools, you have to be responsible. You need to always ask this question, who is going to use this system? And how you are going to use the system. You need to educate people about discrimination because like awareness is really, really matter, right? And we have to define it in the setup. So you should not just be really careless and saying that I'm using this fairness definition. You have to actually think about like what is fair in terms of the product that you are building. And then, of course, like always, when we have the population of different people using the system, if you want to like check the performance of a system, check the performance for all those population and not just overall.